Hello students, welcome to the second part of this binomial distribution video. Now let us do the fifth problem in the worksheet. The problem says a bag containing 3 white balls and 5 black balls. Okay, there's a bag. Let me just draw like a glass. So it has 3 white balls and 5 black balls. Now 4 balls are withdrawn from the bag one at a time in such a way that the first ball is replaced before the next one is drawn. So basically the balls are drawn with replacement. Okay, so n is 4 because I am taking 4 balls at a time. Now I can take getting a white ball as a success or getting a black ball as a success. But here the question is, there are 4 questions. It says what is the probability of selecting 3 white balls, what is the probability of selecting at most 2 white balls, like that. So let me take maybe a success as getting a white ball. So success is getting a white ball. So that means P will be 3 by 8. So definitely Q, that means not getting a white ball, getting a black ball will be 5 by 8. Okay. The first question is, what is the probability of selecting 3 white balls? That means P of X equal to 3. Now let us consider this experiment. The number of trials is finite because it is 4. The second one is there are only 2 outcomes. Either you get a white ball or you don't get a white ball. Third one is each trial is independent and identical, isn't it? Because since we are replacing the ball, whatever happened in the first draw is not going to affect the second draw. And finally, the probability of success remains the same, isn't it? If we take getting a white ball as a success, probability of getting a white ball in the first draw is 3 by 8. Probability of getting a white ball in the second draw is 3 by 8. Likewise, for every draw, the probability of success is 3 by 8. So definitely this experiment satisfies all 4 properties of binomial experiment. So it is definitely a binomial distribution problem. So P of X equal to 3, take a calculator, go to statistics, distribution, binomial, enter BPD because you want a particular, I want for X equal to 3, enter X as 3 and number of trials is 4 and probability of success is 3 divided by 8. So you get the answer as 0.1318, so 0.132, right? The second one is, what is the probability of selecting at most 2 white balls? So P of at most 2, that means X less than or equal to 2. So in this case, go to distribution, binomial, and you need to go to BCD and then put X as 2. You will get 0.8483, so that means 0.848. So very simple. Now the third question is slightly different. What is the probability of selecting a white ball, 2 black balls and a white ball in that order? That means I want probability of white ball, 2 black balls and a white ball in the same order. So now for this you cannot use this BCD or BPD. What you need to do is, you will write it as in fact you can okay, yeah, I can write it as white ball is 3 by 8 into black ball is 5 by 8 into black ball is 5 by 8 into white ball is 3 by 8. So this is the answer, probability of white, black and white in that order. So this is the answer. And the last question is, what is the probability of selecting 2 white balls and 2 black balls? Okay, probability of selecting 2 white balls and 2 black balls. Now, since the number of draws is 4, that means number of trials is 4, saying 2 white balls and 2 black balls is same as 2 white balls, isn't it? If it is 2, if I get only 2 white balls, so obviously the remaining 2 will be black balls, isn't it? So basically what you need to find is, so when I say P of 2 white and 2 black, which is nothing but P of X equal to 2 white balls. So you can go to distribution binomial, go to BPD and put x as 2, which and put x as 2, and then you get 0.3295, so 0.330 as the answer. Yeah, very simple question. Okay, let us look at the sixth problem, students. Biased die in which the probability of 2 turning up is 0.4 is rolled 3 times. Find the probability that, okay, so I have n equal to 4. It is rolled, I'm sorry, n equal to 8, I'm sorry. The die is rolled 8 times. So n is 8. The probability of 2 turning up is 0.4. So I'm going to take a success as getting 2. Success as 2 turning up. So probability of success is 0.4. So normally the probability of 2 turning up in an unbiased die will be 1 upon 6, isn't it? But since it is a biased die, there is more chance of 2 turning up. So first question is, what is the probability that a 2 turns up 3 times? That means P of x equal to 3. So very simple. Go to distribution, go to binomial, go to BPD, put x as 3, number of trials is 8, probability of success P is 0.4. So you get 0.2786 or 279 as the answer. And the second subdivision is, what is the probability that a 2 turns up on at least 4 occasions? That means P of x greater than or equal to 4. At least 4 occasions. That means 4, 5, 6, 7, 8. So instead of that, I will find P of x less than or equal to 3. So I'll go to distribution, binomial, go to BCD, put x as 3. You get 0.594 as the answer. 0.594 as the answer. So the final answer is 0.406. Yeah, the sum is over. Okay, so let us look at the seventh question, student. This is actually an IB question, a past year question. A box holds 240 eggs. The probability that an egg is brown is 0.05. So the questions are, find the expected number of brown eggs in the box, find the probability that there are 15 brown eggs in the box, and the last question is, find the probability there are at least 10 brown eggs in the box. So since we're talking about brown eggs again and again, I'm going to take success as getting a brown egg. So number of trials is, so you say a box has 240 eggs, so n is 240. The probability that an egg is brown, so P is 0.05. Find the expected number of brown eggs in the box. So for a binomial distribution, E of x is nothing but n times P. That means 240 into 0.05. Yeah, so you find the answer. And the next one is, this is A. Now B is, find the probability that there are 15 brown eggs in the box. That means P of x equal to 15. So go to distribution, binomial, go to BPD, enter x as 15, number of trials is 240, probability of success is 0.05, enter, you get 0.073 as the answer, right? And the final one is, find the probability that there are at least 10 brown eggs. So P of x greater than or equal to 10, which is nothing but 1 minus P of x less than or equal to 9. So I'll go to distribution, binomial, I'll go to BCD now, I'll enter x as 9, and I will get 0.2356 or 236 as the answer. So, and the final answer is 0.764. Yeah, this is the answer. Very, very simple question. Now the eighth problem. Jan Jan plays a game where she tosses two fair six-sided dice. She wins a prize if the sum of her scores is 5. Yeah. So let me repeat it again. Jan plays a game where she tosses two fair dice, six-sided dice. She wins a prize if the sum of her scores is 5. That means if she gets, let's say, 2 and 3, or if she gets 3 and 2, or if she gets 1 and 4, or 4 and 1, she'll get a prize. Jan tosses two dice once. Find the probability that she wins a prize. So A is, what is the probability that she wins a prize? Okay, so the answer is very simple, isn't it? The answer is 4 upon 36. Now how is this? Now when she tosses the two dice once, there are 36 possible outcomes, isn't it? You can have let's say 1 1, or you can have 1 2, or you can have 1 3, till you can have 1 6, or you can have 2 1, 2 2. It goes on. Finally you can have 6 and 6. So there are 36 possible outcomes, out of which there are 4 favorable outcomes. What are these 4? 1 4, 4 1, 2 3, and 3 2. So these 4 outcomes will give a total of 5, in which case she will win the prize. Yeah, very simple. Now the second one is, Jan tosses the two dice 8 times. Find the probability that she wins 3 prizes. Now here we need to use the calculator. So number of trials is 8. Okay. Now success is getting a prize, which is nothing but 4 by 36. Yeah, just now we found it. So 1 upon 9. Okay. Now I need to find what is the probability that she wins 3 prizes. So I need to find P of x equal to 3. So go to distribution, go to binomial, go to BPD, put x as 3, number of trials is 8, and probability of success is 1 divided by 9, and the answer is 0.0426, so 0.043. Yeah, that is the answer. Okay, let us look at the ninth problem. A multiple choice test consists of 10 questions. Each question has 5 answers. Only one of the answers is correct. For each question, Joe randomly chooses one of the 5 answers. Okay, so that means the probability of him getting a correct answer is 1 by 5. There are 5 choices and only one of them is right, and he is choosing it randomly. He doesn't know the answer, right? So probability of him getting a correct answer is, answering correctly, is 1 upon 5. Okay, so here there are 10 questions, so n is 10. The probability, the success is Joe's getting a correct answer, so which is nothing but 1 upon 5. Now the first question is, what is the expected number of questions Joe's answers correctly? So that means E of x, that is mean, which is nothing but np 10 into 1 by 5, that means 2. So out of 10 questions, that he is expected to get 2 questions, 2 answers correctly. Now B, find the probability that Joe answers exactly 3 questions correctly. So I want P of x equal to 3. So go to distribution, binomial, go to BPD, put x as 3, number of trials is 10, and probability of success is 0.2. You get 0.201 as the answer. And the C part is, find the probability that Joe answers more than 3 questions correctly. That means P of x more than 3. That means 3, 4, 5, 6, 7, 8, 9, 10. So the easiest way is 1 minus P of x less than or equal to 3. Now you need to go to BCD and then put x as 3. Execute. You get 1 minus 0.879 as the answer. So 0.1 1 2 1. Yeah. So the problem is done. I hope this is clear to you students. Okay, the next question. A factory makes switches. The probability that a switch is defective is 0.04. The factory tests a random sample of 100 switches. So the n is 100, number of switches that are sampled is 100, so n is 100, and the probability of finding a defective switch is 0.04, right? And the questions are, first question is find the mean number of defective switches in the sample. The second one is find the probability that there are exactly 6 defective switches in the sample. And the third question is find the probability that there is at least one defective switch in the sample. So everywhere we talk about defective switches. So what I'm going to do is I'm going to take success as getting a defective switch. So success is getting a defective switch. So P is nothing but is given there 0.04. Yeah. The first question is find the expected or the mean number of defective switches. That means NP. So 100 multiplied with 0.04, which is nothing but 4. And B part is find the probability that there are exactly 6 defective switches in the sample. So P of x equal to 6. So I'm sure you know where to go. Distribution, binomial, go to BPD and substitute x as 6. Number of trials is 100 and probability of success is 0.04. So you get 0.105 as the answer. And the C part is find the probability that there is at least one defective switch. So P of x greater than or equal to 1. So which is nothing but 1 minus P of x equal to 0. So you can go to BPD again, put x as 0, get the answer. You get 0.017. That means 0.983 is the answer. Right? Very, very simple question. Quite an easy problem, an IB question. Okay, fine. There are only 3 more problems in this worksheet. The 11th problem. The probability of obtaining heads on a biased coin is 1 by 3. Now, Sammy tosses the coin 3 times. Find the probability of getting 3 heads. Okay, so A, P of 3 heads. Okay, so he is tossing it 3 times. So 3 heads is nothing but 1 by 3. First time head, the second time head, and the third time head. So which is nothing but 1 upon 27. What is the probability that he'll get 2 heads and 1 tail? So that means P of 2 heads and 1 tail. So you get 2 heads means 1 by 3 into 1 by 3 and 1 tail is 2 by 3. Isn't it? Getting a tail is 2 by 3 in that biased coin. Now into 3C2. Why 3C2? Because he's tossing it 3 times and out of 3, 2 times you're getting a head. So 3C2. That is the answer. Now let's look at the B part. Amir plays a game in which he tosses the coin 12 times. Find the expected number of heads. So N is 12 and find the expected number of heads. So mean, I want mean. So NP. So 12 times 1 by 3, which is 4. So he is expected to get 4 heads. Now Amir wins $10 for each head obtained and loses $6 for each tail. Find his expected winnings. Now it is mentioned that he will get $10 for each head and he'll lose $8 for each tail. And it is also, just now we found out that he's expected to get 4 heads, isn't it? He's expected to get 4 heads. That means he will get 8 tails, isn't it? As it is mentioned in the question that he's playing the game 12 times. 4 heads means 4 into $10, and 8 tails means I'm sorry, it is I think $6, right? He is losing $6 for every tail. So 8 into 6, So you get 40 minus 48, that is minus 8. So he is actually expected to win minus $8. So basically it means he is expected to lose $8, right? Okay, now the 12th problem is, a factory makes calculators. Over a long period, 2% of them are found to be faulty. So 2 out of 100 calculators are found to be faulty. A random sample of 100 calculators is tested. So there are 3 questions. First one is, write down the expected number of faulty calculators in the sample. Second one is, find the probability that 3 calculators are faulty. The third one is, find the probability that more than one calculator is faulty. So we are just discussing about faulty calculators. So I will take it as success. So n, number of trials is 100 because we are taking 100 samples, and success is getting a faulty calculator. Getting a faulty calculator is a success. So P is 0.02, isn't it? 2%. Now the first one is, what is the expected number of faulty calculators? So that means n into P, that means 100 into 0.02, which is 2. So we can expect 2 calculators out of 100 to be faulty. Find the probability that 3 calculators are faulty. That means I want P of x equal to 3. So take a calculator, go to distribution binomial, go to BPD, put x as 2, and number of trials is 100, and probability of success is 0.02. So you get 0.273 as the answer. The final one is, find the probability that more than one calculator is faulty. That means P of x more than 1, which is nothing but 1 minus P of x less than or equal to 1. So go to BCD and put x as 1, and you'll get 0.403 as the answer, which is nothing but 0.597. Yeah. Now the final question of this worksheet. A box contains 35 red discs and 5 black discs. A disc is selected at random and its color is noted. The disc is then replaced in the box. So you have 35 red discs and you have 5 black discs. Okay. So a disc is selected at random and its color is noted. The disc is then replaced in the box. So that means we are replacing the disc. In 8 such selections, what is the probability that a black disc is selected exactly once? What is the probability that a black disc is selected at least once? So number of trials here is 8, because 8 such selections. I'll take success as getting a black disc. So that means P is 5 by 40, which is nothing but 1 upon 8. And I need to find probability of getting exactly one black disc. So P of x equal to 1. So P of x equal to 1. So go to distribution binomial, go to BPD, put x as 1, and number of trials is 8. Probability of success is 1 divided by 8. So you get 0.3926 or 393. Second one is, find the probability of getting at least one. So P of x greater than or equal to 1. So which is nothing but 1 minus, greater than or equal to 1 means 1, 2, 3, 4, 5, 6, 7, 8. That's quite tedious, isn't it? So I'll find P of x equal to 0. So 1 minus, I'll go to BPD, put x as 0 and get the answer. I'll get 0.3436 or 0.344. So the answer is 0.656. Right? Okay. The final one is the process, B. The process of selecting and replacing is carried out 400 times. What is the expected number of black discs that would be drawn? So again NP. Now this time n is 400, not 8, isn't it? because it is mentioned clearly that the process of selecting and replacing is carried out 400 times. So number of trials now is 400, but the probability of success remains the same, 1 by 8. So you get 50. So you expect to draw 50 black discs. Yeah, so that's it. So I hope these two videos are quite helpful for you to understand the binomial distribution. Binomial distribution, as I mentioned earlier at the start of the previous video, it is a very simple concept, right? And most probably it will be a calculator question. So you need to know what is n, what is success, then what is the probability of success, and finally how to use the calculator, when to use BPD and when to use BCD. So if you know all these things, definitely you can do very well in these in the problems involving binomial distribution. Yeah. Thanks a lot for watching this video, students. I hope this is helpful to you. Thank you.